This sample problem will lay out a building within a traverse that was previously calculated. The calculation of the traverse is a separate sample calculation that you can review. So after we've determined the directions of each of the lines of the traverse, which then got us our coordinates of our points A, B, and C, we also have been given our building corners coordinates, points 1 through 4, for our structure. So from here, we'll be able to determine what those distances are from whatever given point we've decided to set up. So if we set up our instrument at point A, we'll be able to run distances to each of the building corners, as well as angle to turn to each of the building corners to determine what exactly or where exactly the building will be located on the job site. So we'll use the information given to us on the sketch as well as the table that has the coordinate data for each of the building corners. And we're going to have to calculate the layout data, which means the direction and distances to each of the building corner points. We're going to radial stake them. And what we're going to do for this is set up at point B and have a back sight on to point C as our 0 point. If we look back at our sketch, that means our instrument will be set up at point B, and what we will do is set up point C as our 0 line. So what we need are numbers off of our point C, not off of our north, which we will be turning all of our angles on. We're going to just use our point C as our back sight. So first off, we're going to be looking at our distance for each of our building corners. It is actually the easier one to look at, looking at our Pythagorean theorem. So our distance equation is going to be the square root of our north coordinate difference squared plus the east coordinate difference squared. So if we're looking at building corner number 1, the coordinates we have for building corner number 1 are north 4984.18 and east 1080.62. Since we are setting up at point B, this is where we're going to base all of our calculations off of. So B's coordinates are north 4817.967 and east 10405.046. So building corner number 1 to B. Make sure you pay attention the direction you're going. We're going B to 1. So this means that this is technically our first point, and this is our second point. B will always be our first point in all of our calculations, but our second point will change whether it's building corner 1, 2, 3, or 4. But don't get messed up that position 1 and position 2 will change. You're always looking at where you're going from to where you're going to. It's not as impactful in our distance because we are squaring our numbers, but we want to make sure that we keep it straight. So if we're looking at B to 1, it means that we are going to take the difference of our north coordinates, so 4984.18 minus 4817.967, that value squared, and then the difference between 1080.62 and 10405.046. That value comes to 364.526. It's a distance, so it will be in feet. You'll do this exact same calculation for all of your building corners. So if we're looking at B to 2, what changes is our first coordinates. Those change to our building coordinates for corner number 2. So we also need to do B to building corner 3 and B to building corner 4. I'm not going to run out all of those equations. Just know that the numbers you are changing will be your first numbers to whatever building corner you're actually at. So the remaining calculations will show us that we have a B to building corner 2 distance of 227.019 feet. From B to building corner 3, 339.306 feet. And B to 4 of 177.625 feet. Again, just changing out those first coordinates for whatever building corner you are on. The second part is the direction. So our direction calculation is the arc tangent of our east difference divided by our north difference. And here, positive and negative is very important. We will always have our second location subtracting out then our first location. So N2 minus N1, E2 minus E1. So what that means is not building corners 1 and 2. Our B is always going to be our 1 location. Our 2 is always going to be our building corner location. So that will change how our numbers are set up. So for building corner 1, we will have the arc tangent of 1080.62 minus 10405.046 over 4984.18 minus 4817.967. So if we do that calculation, we will have a negative 62.8726 as our answer. We need to be careful. We need to keep in mind where we are in our coordinate. If we look at our sample problem, we're going from point B up to building corner 1. If we put our crosshairs at point B, we can see that we are going around to our quadrant number 4. So 1, 2, 3, 4, which means we are here, and the number that we're given is actually negative. It is going in reverse. So when we are looking at trying to get our correct number, we have to take our 360 minus the 62.8726, and we would end up with 297.125. That will give us our full azimuth going all the way around rather than our bearing number. If we want to do a conversion to get our 297.127 into degrees, minutes, seconds, if we did that, we could see that we have 297 degrees, 07 minutes, and 39 seconds. So the remaining calculations would be all the same. Again, what will change are these first two numbers. They will be building corner 2, building corner 3, and building corner 4. Our point B numbers will remain the same for each one. So B to 2 would be 318, 36, 5. B to 3 is 287, 23, 7, and B to 4 is 306, 59, 25. So What this gives us, however, are these numbers off of our north, so our complete azimuth. Those don't actually give us the true number that we're looking for when we go to lay out our structure. As we said, we look at our crosshairs. We know our structure is in quadrant 4. So if we have our line that is point B to point C, what we have just determined are the angles and azimuths all around from basically B to building corner 3, or for example, same thing but coming around, in this instance, building corner 4. But when we go to lay out our structure, we won't have our azimuth to go off of. What we will have is a back sight onto point C. So what we really want, for example, from B to 4 is simply this angle here, the short distance from C to 4, as well as C to 3. So we will take all of the numbers that we just calculated, and we will subtract our direction, BC, which is 284.12. So from B to 1, it will be our 297.0739, subtracting out 284.12. 12:55:39 is the actual direction, the angle of what we're looking for, and that will coincide with our distance of 364.526. We can do the same for 2, 3, and 4. Subtract out the same 284.12, gives us 34.24.5. 3.11.7, and 22.47.25. So these are all of our angles that we're finding. So when we say we're calculating the layout data, we need to figure out our angles for each of those off of whatever back sight is determined, as well as the 4 distances for building corners 1, 2, and 3. Building corners 1, 2, 3, and 4.